Hello everybody and welcome back. Welcome back. I hope everybody's doing well. So we're gonna get into lesson 8. Okay, lesson 8 here. We're still doing optical phenomena and properties of materials. So for lesson 8, we're gonna do question 10 here. This is question 10, and it comes from Free State. This is Free State September 2023, and this is what we're gonna use for our lesson 8. Okay, so let's read the question together. They say a learner uses 2 photoelectric cells to determine the maximum kinetic energy of photoelectrons from calcium and sodium cathodes. Monochromatic light from the same source is shown on the cathode of each photoelectric cell, as shown in the diagram. Okay, so now, and then below the diagram, okay, so we have the diagram here. The metal is here, and then the electrons are ejected here, and they are ejected from the cathode to the anode. And so that the ammeter records a small current in each case. Okay. The learner compiles the following data for the 2 metals. Okay, so for calcium and for sodium. Okay. So for calcium, we have both the work function and the maximum velocity. For sodium, we have the work function and the Vmax is missing. So 10.1, they say define the term work function of a metal. So we can see that this term is important because a lot of times they ask you for the work function. Okay, you should know it, how to define the work function of a metal. So for 10.1, they say define the work function of a metal. The work function is what? It's the minimum amount of energy required to eject electrons from a particular metal surface. The minimum amount of energy required to eject electrons from a particular metal surface. This is a very important definition. You should know the definition here is very important because it is asked a lot of times in the majority of the questions. And then we go to 10.2. Use the information in the table to calculate the wavelength of the light used in the experiment. Okay. The wavelength of the light used in the experiment. Okay. We can use calcium here. Okay. Because we have the work function and we have the maximum velocity. Okay. So we are going to say E. equals to function plus ek max. And then we have to change the ek, the kinetic energy here, such that we have the speed. We have the speed over here. And then here we have to change the e such that we have the wavelength, because what they're asking us is for the wavelength. So we're going to say hc over wavelength equals to wo plus half m, then v squared max. Okay, then if we are looking for the wavelength, it means we have to change the subject of the formula. So the wavelength should be taken to the right side of the equation, and then everything on the right side of the equation here can be brought under here, okay, such that we have something like this. So it's going to be, we take everything on the right and then we take it below, then it's going to be half m and then v squared max, and then hc, and then equals to the wavelength. Okay, and then so we just swapped. We took the wavelength this side, then we took everything this side where there is the wavelength. So then we can substitute at this point. So then we can make a substitution. And then the work function here we can use for calcium, which is 3.36, 10 negative 19. So we say 3.36, 10 negative 19, and then plus half. Seven point one four multiplied by 10 to the power 5, and then squared equals to the wavelength. Then HC here is going to be 6.63 multiplied by 10, negative 34, and then 3 times 10 to the power 8. And then it's going to be 3.50, 10 negative 7. 3.50 multiplied by 10, negative 7 meters. And then we go to 10.3. So if we use a calculator there, this is what it gives us. 10.3, they say, calculate the maximum velocity of an ejected electron from sodium metal. Okay, the sodium metal. So then we're going to use the work function for sodium this time. So we're going to use 3.65. Okay, because this is the work function. So we use the same equation. Okay, so we say E equals to work function plus ek max. So you just have to write down the equation, okay, because sometimes there's a mark for the equation, okay? So do not skip the step here. It's important. And then we say hc over wavelength. So since we have the wavelength now of the light, we have it here. It's going to be equal to the work function plus half mv squared max. Okay, this is it. And then so hc over wavelength minus w equals to half, then m 2hc over wavelength minus 2w equals to m, and then v squared max. And then at the end of the day, when we make v the subject, it's going to be, because we still have to divide by the m here, so it's going to be therefore square root, then 2hc divided by m, then wavelength minus 2w divided by m. Vmax. So you just divide by m here, then you also divide by m there. Then after that, you take the square root. So the m is the same. So then we can substitute. Okay. So then we can say therefore so it's 2 multiplied by 6.63 multiplied by 10 negative 34. And 8, then divided by the m, which is 9.11 negative 31, and then 3.50 multiplied by 10 negative 7. Yes, and then minus 2, then multiplied by 3.65, and then 10 negative 19, then divided by 9.11 multiplied by 10, and then negative 31. And then this is equal to Vmax. So then you just have to use your calculator there. So then Vmax equals to, so you put everything here inside a calculator. Okay. The square root includes everything. So the work function there, let me just double check. Is it 3.65? Yes, it is 3.65, 10, negative 19. So we put all that into a calculator. 263 divided by 9.11. Okay, it gives me 6, so in scientific notation, it's gonna be 6.68, and then multiply by 10, exponent 5, and then meters per second. This is what it gives me. It's the Vmax, which is the speed that they're asking for here. Maximum velocity, yes. So This one again. Okay. So the biggest thing was to change the subject here. To change the subject of the formula. Yeah, okay, so this is work function. Okay. It's W naught. I forgot the naught here. The work function. So that is the maximum speed. So now let's go to 10.4. 10.4, they are saying something. The intensity of the incident light was increased. How does the change affect the reading on the ammeter? Write down increase, decrease, or remains the same. Explain the answer. Okay. So the intensity of light will increase. The reading will increase. Okay. So the intensity increase. So the explanation here is going to be more photons will reach the metal surface per unit time. So it means more photons of light will reach a unit time. So this means that more electrons will be ejected. On the metal surface per unit time. So this will lead to an increased current. So it means the current will now increase, because if there is more electrons ejected, there will be a higher current flow. So it will lead to an increase in the reading, in the ammeter reading. Okay. So this is the end of lesson 8. I hope that was helpful. And thank you again for watching. Thank you for tuning in, and I hope that you got something from here. I hope to see you on the next one. And leave your questions in the comment section, please. Let us engage. Let me see what you find confusing. Okay, so ask me all your questions and I will explain everything that you don't understand. Okay, so bye-bye for now, and I will see you on the next one. Take care.